Hi, everybody. If you're just joining in and you have any questions you want answered during the Q&A, please type them in the chat. I do have a few that I'm going to start with, but after that, I don't have anything prepared. There is no lab worksheet tonight because there's none this week. So please type in questions you might have. We'll go over them when the Q&A starts at 5 p.m. See you in a bit. Hello. So I got an email from a student today asking about. I gotta find the email. Where is it? Asking about some of the Lab 1 worksheet stuff and some Lab number 2 stuff, and then. Oh, yeah, that's it. So if that student's here, I think it's Karen. Is Karen here? So I have your questions here. I'll answer those first, and then looks like Heidi has a question about the lab. And they might be the same question, so let me just go over them one at a time here. Let me see if I can do this. If I paste this in here, what will happen? It will be really tiny. Excellent. And it will be it'll be centered for some reason. So, okay. So here's the question that I got. Hold on. I'm going to try and format this so that it's bigger. Text. So select all. It doesn't need to be centered. That's better. Okay. Actually, that's too big. It doesn't fit. Okay. I realize that's probably a little bit hard to see. Hopefully everybody can see that adequately. So question 25 on lab number 1. So I gotta get that. So give me a second to find that folder. That's 161. I want the other class. Online labs. So let me put this over here. It's going to cover the chat for a second. Actually, let me move that so it doesn't. So the question was 25 and 6. Is this right? Let me see here. I think that that's what's intended. Okay. So yeah, number 25. So copper has a density of this. If this is a penny's weight, what is its volume in liters? So what we can do. So I know that the density. Oops, I got to move my pad a little bit back. Oh, and I'm not even on a pen. There we go. Oh, yeah, I got to do that. Okay. So now I should be able to draw all over it. Okay, cool. All right, so I know that the density of copper is this. So 8.96 grams per cubic centimeter. And I know what the mass of a penny is, and that's this, 3.05 grams for a penny. And what I want to do is I want to go from grams to get to liters. Now, in order to go from a mass to a volume, I have to use density. That's the only relationship we have between mass and volume. So that's right here. So I could turn grams into cubic centimeters. And then in your lab prompt is something that tells you the relationship between cubic centimeters and milliliters. And that's actually this. 1 cubic centimeter and a milliliter are the same thing. And then this relationship, we should know that there are 10 to the minus 3 liters in a milliliter. That just leaves the density relationship, which is actually right here. So if I set up my units, what I can do then is I can say grams, cubic centimeters, and the density will eventually go in this spot. Then cubic centimeters to milliliters, and then milliliters to liters. And I didn't cross these out, that's okay. So now I'm going to fill in the numbers. So 8.96 grams, so this goes down here, per cubic centimeter. These are the same, so they're both 1. And then in a milliliter are 10 to the minus 3 liters. And I got to get my calculator out. Oop, my pen just clicked on something even though I set it to the side there. Let me just put it up here where it's away from it. 3.05 times 10 to the minus 3 over 8.96. And so the number that it spits out for me is 3.404017. I'm going to just write 3 sig figs because that's what these numbers have. Times 10 to the minus 3. Oh, sorry, not 10 to the minus 3. Oops. 10 to the minus 4 liters. So this is the answer that you should have got. Now this has 3 sig figs because this number that you start with has 3 sig figs. And also the density has 3 sig figs. Everything else that's used in here is an exact quantity. So that's number 25. And then number 6, I think 6 is a temperature question. Yeah, a lot of people had trouble with the temperature questions. Because I think what people forgot was that temperature conversions are either exact or inexact depending on what conversion you're doing. So Fahrenheit Celsius has an exact component, but the Kelvin one has an inexact component. And we're doing combined operations, so it's all sorts of craziness. So This is number 6. I want to do this, and I want this as my output. Now, I never remember the formula for temperature, so I have to look it up every time. So I am turning Fahrenheit into Celsius. So here's the formula in the lab text. It is this 5/9 times whatever your Fahrenheit is minus 32. And these numbers are both exact. And what that means is this 32 is actually this 32.00000 ... forever, because it's exact. So when I put this in the equation, I would then have 5/9, which is also exact, times whatever my Fahrenheit is, minus 32. Now this goes to the hundredths place, and this is exact, so it doesn't affect my answer. So when I do this parenthesis right here, and this 5/9 comes out in front, I will still report an answer that goes to the hundredths place. So 6.25 minus 32 is negative 25.75. So this number as written was calculated to the correct number of sig figs. And then when I times that by 5/9, if my calculator would work with me here, I then get negative 14.31 degrees Celsius. Because this number has 4 sig figs, I should do it a different color. This is 4 sig figs. This is exact, so my answer should also have 4 sig figs. And this is lab number 1. So the key should say 4 sig figs. And if you had a different number, I think it's really common for people to do either 2 or 3. And then, what was the last question? I got to scroll up and look at that. On question 8 in lab number 2, I got to get that PDF, so just a second. That's this one. So it doesn't have 3 for 6.25 because when you do the subtraction here, right here, 6.25 minus 32 is an exact number. 32 is the exact number. This isn't, so I punched in my calculator, and then I used the subtraction rules, and I got to keep it down to the hundredths place. So I got to keep this number because it's known. Then this number has 4 sig figs, and so my answer will have 4 because it's multiplication. Yeah, so it's the addition and subtraction parts that always get people. Because you look at those numbers and you're like, oh, I start with 3, so I should end with 3. But if you have addition and subtraction, that is not always the case. So be very mindful that when you are doing addition and subtraction, you got to look at decimal places. You got to set it up vertically and solve it. The question on the lab, for question number 8, I have you watching a video about rusting nails. And then the question says, cite evidence that the chemical change has taken place in any of the containers, specify which. You choose any one you want. You should probably choose a container that has a chemical change. For example, one of them seems to not. Some of them may seem to not. I don't want to spoil it, actually. But there will be some that are very, very obvious. And so what I want you to do is tell me, why was it obvious, right, in your response? What led you to think, oh, yeah, obviously chemistry happened there. You can pick anyone you want. You don't have to do all of them. You just have to do one. And then question 4 for video 2. Give a chemical property of water. So when I ask you about chemical properties, what I mean is, what is a property of this substance that causes it to undergo chemistry? And so in the video, something has happened, and a chemical reaction has occurred. And what I want you to do is tell me what caused that, because that would be a chemical property of water. So, for example, if heating water caused it to decompose, like shown in the video, you would say that water is not temperature stable. It decomposes. That, it turns out, is not true. Water's very stable. It ends up boiling. It stays water. But something specific about the video caused the water to undergo a chemical change, and I want you to write that as a chemical property of water. Water will decompose into X and Y when blank, and then fill in the blank. Question 3 on Lab 2. For the video on top of the battery, are the bubbles forming evidence of chemical change? That's really strong evidence. So if you look at the water's not boiling. Now, I wish that there was a thermometer there to show that, but the water is actually being split into different things. And the video tells you what those things are, and then it tells you a little bit about like how you know. So I would say that bubbles forming is a really good sign that a chemical change is taking place, but it's not universal. For instance, if I heat water, bubbles form, but that's because you're making water as a gas, and that is not a chemical change. Hopefully that helps you. That might be all the questions I've got so far. Are there other questions about anything at all? And let me scroll this back down so that people can see it here. There we go. Where is my... There it is. Okay. Hopefully the videos are entertaining. I actually had a lot of fun watching the videos when I was, like, picking them out, because I had to pick, like, 4 or 5 for the assignment. And I just sat there and watched videos all night, and then I was like, oh, I have to actually write the report. Crap, I have to do work. I'm just sitting here watching how it's made. I had a different one for how it's made. I had the American version, but I wasn't super happy with, like, what they showed. In the sense that I thought it was really hard to, like, figure out physical properties of the aluminum from what they were doing. There was one really obvious one, but I couldn't find a second one in that video that would be really easy for you to identify. But the one I linked, I think, is very obvious, like, what the physical changes are. It's question number 7 that I think is the hard one. That one I gave you a hint for, that's why. Other questions. They don't have to be about Lab 2. You can ask me questions about anything except for Quiz 2. Also Quiz 3. I can't answer Quiz 3. But Quiz 1 is okay. Because that one's done. You can also ask me just any question at all, really. As long as it's appropriate for class and not, like... Yeah. I couldn't think of an example. Do do do. Do do do. 329D. The most abundant isotope and the second most abundant isotope both react with chlorine to give a green compound. What's the context of that question? Actually, do I have the book? Let me go grab the book. I'll be right back and see if I can find that. Give me just a second. Alright, so I have the book here. Let me see if I have the same 329. Because I have the store version of the textbook. Oh, I see. Okay. So what the question is asking is that you have, we'll call it X. X is the most abundant isotope of an element. And then Y would be the second most abundant isotope. And then for questions A through D, it's asking you which of these is true for both X and Y. So A, for example, says the mass number is 70. Well, if the mass number is 70 for one of them, and the second one is an isotope, it can't be 70. It would have to have a different mass number. So that one can't be true. And then going down the list there, if you go to D, so if X reacts with chlorine to give a green compound, and Y is its isotope, what does that tell you about how they would behave? Do isotopes behave chemically differently? Or are they identical? That's what the question is trying to get you to ask. Or to answer, actually. Another way to say it is you could replace the mystery element with any element. So like, say, iron, for example. So if one is iron 55 and the other is iron 56, would they both react the same with chlorine? And that's more or less testing your knowledge of what isotopes are. Are isotopes chemically different, or are they chemically identical and just physically different? One of those two is correct. So the answer is yes, they would be the same, but how come? That's what I want you to answer. They do react the same. Now, why is that? What feature of an atom is governed by isotopes? Like, what does that mean? What are we changing in the atoms to get different isotopes? Oops, I just dropped my pen. So another way to put it is, let's suppose I did a reaction with carbon. Like, I burn carbon. Does it matter if I'm burning carbon 12 or carbon 13? For instance, let's suppose that you have charcoal and you set the charcoal on fire to, like, cook steak or something. Now I'm just hungry, that's all. Carbon is just randomly either carbon 12 or carbon 13. 99% of carbon is carbon 12 and 1% is carbon 13. But the charcoal briquette will just burn regardless of what carbon it is. And so it turns out that with elements, all we care about is their identity when we are looking at their reactivity. But remember that isotopes differ only based on the number of neutrons that are in the nucleus. Do neutrons do anything, really? What have we said that neutrons do so far? Yeah, you're on the right track. What do neutrons do? Well, there's a slide where we talked about the nuclear force. Neutrons just hold protons together. So if you add more neutrons in there, they hold them a little better, but that's all. Nothing about the atom changes otherwise. So the chemistry is the same. And in chapter 4, we're starting to learn that all the chemistry that happens with bonds and stuff, it's all electrons. So if you don't change the number of electrons, you don't change the chemistry. But if you change the number of protons, so for example, changing from carbon to nitrogen, I just dropped my pen again because I'm klutz. When you change the number of protons, you also change the number of electrons on the outside. And so that will cause a different reaction between carbon and nitrogen than, say, one isotope to the other. So that's what that question is trying to ask you. Now I put the pen on the book and it just rolled right off, so that's just great. You know, I'll just put it right there. Yep, that's exactly right. So when you have different combinations of neutrons in the center of the atom with the same number of protons, those are isotopes. Remember, same Z, different A. Oops. Let's do that. No problem, that's what I'm here for. Other questions? Otherwise, I will just draw a pig. I don't know. I mean, I have this tablet. I gotta draw something, right? I didn't give him an ear on this. Question 4. That's the battery one, right? Oh, yeah, I think we answered that question earlier. So what I want you to do for question 4 is tell me what property water has that makes it react like that. So you could just say, a property of water is it is reactive when, and then you tell me what causes it to react. Like spilling water doesn't make it react, so that's not a chemical property. But doing something to water makes it react, and so you have to tell me what that is based on what you saw in the video. And you can be general about it. So like you don't have to be specific about the circumstances in the battery. You could just say like, oh, if I do X to water, it will split into pieces. and make a gas. Oh, my textbook is falling apart. That's no good. Other questions? So the baking soda in the water is needed to facilitate the reaction. It just helps it go a little faster. If that's not in the water, I believe that it still works, but you need you need a bigger battery, basically. Oh, excuse me. You need a bigger battery. So the baking soda facilitates it. And you can include that in your answer. So chemical properties of things could be something like, in the presence of this, water will react. Hey, you're not from 121. For 121, the quiz deadline is the 11th, and I updated that on that video. The current banner is for this class, which has different deadlines. So if you're looking on the current screen right now and going, "Oh shit, I didn't know that was due tonight," it's not. It is for this class though. So 161's quiz is due the 11th, and that was a typo when I first put the banner up that day or this afternoon, and that should have been fixed for the video. But the current banner is correct for this class, which is 121. Or it better be. I did edit it. No problem. Other questions from students? I can't draw anymore on my pig. It's done. So I guess I could give him a name. I think that's a good name. I would name my pet Delicious. Just ironically, I would never eat my pet. My pet pig, I mean. All right, so last call for questions. If you got anything, type it in the chat. Otherwise, this piggy is out of here. Oh, where'd he go? I don't know. I deleted him. Oh, he's back. Where is my thing? There it is. Alright, well, it doesn't seem like there's much else left, so we'll put this back up. I'm gonna put the music back on. Oh, thank you. Yeah, I'm not an artist. I'm gonna put this back up. I'll put the music back on. I'll leave the stream up for like another minute or two in case you want to type something in to ask me real quick. Otherwise, we'll call it a night here. Thanks for stopping by. Tomorrow's lecture will be over the rest of Chapter 4, and then we will begin Chapter 5 and keep going from there. Thanks for watching, and have a good night.